How is your preparations on going into the new year? Hopefully good, assuming the same. So let us see this question which I have taken from physics, this numerical, okay, where a body of density rho dot is drawn from a height h, right? So the body is drawn from certain height and that height is nothing but h, right? So let us say this body is there, okay, of mass m, right? And this is drawn from a height h. So let us say if this is a lake over here, right? This is the surface of the lake and the body is dropped from here, okay? Dropped, that means there is no initial velocity, right? And the height from which it is dropped is h, is given to you. You can see a body of density rho dot. So rho dot is the density of this body with a mass m, right? Where m is the mass. Okay, so let me write this is the body which we have assumed, right? Now it is dropped from a height h, you can see, into a lake of density rho and rho greater than rho dot. That means in this lake, this water is also, lake water is also having certain density, and density of this lake water is rho, right? And it's given that rho greater than rho dot. That means which the density of, if you compare the density of the body and the water, then definitely rho greater than rho dot, what it reflects, that it reflects that the density of water is high. That means the body will not sink inside it, but it will float inside the lake, into the lake, right? We can say like this. So this figure reflects this. You need to understand each and every figure or data given into the question. Here it's given that rho is greater than rho dot. That means this body which is having the density rho dot is definitely less than rho. That is the, and rho is the density of lake. You can see. That means this body will not sink inside, it will float. This is confirmed that this body will float. Rho greater than rho dot, it reflects that, right? So what is the depth to which body sinks? So that means the body is dropped from a height h, definitely due to certain velocity which is acquired before striking the surface of the lake, it will go inside like this, right? And after reaching a certain height, or we can say not height, depth, you can see what is the depth. This is being asked. So after going inside the water up to a certain height, let us say y. We should not say height, basically it's depth. It goes and after that it returns back. It returns back like this, right? Because it is going to float in the lake because rho greater than rho dot, right? This is the figure. Now first of all, my dear friends, we need to understand what is, just break the total actions which is happening over here into two parts. Okay, first let us see the actions happening in the air, right? So if this is position A from the body, where from where the body is dropped, that means the initial velocity over here is nothing but zero, isn't it? U, the initial velocity is 0, right? And after that it acquires certain velocity. Let us say this velocity is v, right? Let us say this velocity is v and this position is b. This is b, right? And this position is c. So what we will do, my dear friends, we will see what is happening across AB and what is happening across BC. So we'll break this entire situation into two sections and see and what are the granular level of actions which is happening. So if you consider the act for the path A to B, that means in the air, that is before striking lake surface. I hope you understand what I want to say. That when the body is dropped from here and it strikes the lake surface, this will be the height. If you remember the formula, V square minus U square is equal to 2AS, right? Then here you can see V is the velocity with which the body strikes the lake, right? So this can be found out. How? Because U is 0 in is because it is dropped. The body is dropped from this point. Dropped means you are just dropping it, right? So U will be 0. So this will give you V square is equal to 2, and it is going under the gravitational force. So that's why the acceleration over here will be equal to G, and S is the total displacement. So for the section A to B, this is A and this is B, right? From A to B, the height is H. This is H is the height. You can see this one. H is the height. So this is equal to, this will be the value of displacement, right? You can write like this, right? Now when you take the square root into both the sides, you will get the value of V, that is the velocity with which this body strikes the surface of the lake. That means just before entering the water, right? So V is equal to root over 2 into G into H, right? This is a relation or the value which you derive, right? Now my dear friend, from this point just go to the second section, B to C. B to, let me write it over C again. So B to C, what will happen into B to C? So first of all, try to understand if the body is here inside the water, okay, then maybe the direction of the body will be towards down, right? So it will be MA here, right? It will be MA here, and the weight of the body also acting here, that is mg. I'm saying the point where the body is dipped inside the lake, going like this. So acceleration of the body will be towards the depth, towards the bottom of the lake, right? So if we draw the free body diagram of body in the lake, what are the forces acting on it? First, the buoyant force, which will just try to push the body upward, right? It is saying rho greater than rho dot, so say that no, Mr. Body, you cannot dip inside me. Go to the surface. You need to float like this, right? So this will be the buoyant force, right? Force of buoyancy. And apart from this, the weight of the body which is acting downward, that is equal to, which I said, mg, right? So this will be mg, and since the body is going downward with certain acceleration which is imparted by this velocity, the velocity that is equal to root over 2gh, right? So this is equal to m into a, isn't it? Now if you draw the free body diagram of the body into the lake, the forces acting on it will be force of buoyancy upward, mg acting downward, and ma acting downward, right? So but you can see ma is the driving force. So just write the forces like this, as we already seen multiple questions, and we can derive from the free body that ma is the driving force. So ma will be into the one side of the equation, and that will be equal to, since going downward, so the mg impact of mg will be higher than the buoyancy force. So definitely mg will subtract force of buoyancy or buoyant force, right? Mg minus b, right? Now this will give you mg minus b equal to ma, right? Now from this point, what we can say, that yes, if ma equal to mg minus b, and we know that b is nothing but rho z v, right? B, buoyant force, is nothing but, this is buoyant force, this is equal to rho g v, right? So rho gv, this is the volume, okay? This is the volume, don't get confused. This is the value of buoyant force, and mg, m into g, can be written like this, m into g and m into a. Just keep it as it is, right? Now we know that mass by volume is equal to density. So for the body, the density is rho dot, right? So can we write m as equal to rho dot into v? Can we write it for the body, right? So in place of m, just write rho dot v, right? Then we can write rho dot into v in place of this m, right? Into a, into a is equal to, for this m with mg, just write rho dot v. So it will be rho dot v into g minus rho g v. This is the buoyant force, this is the buoyant force, right? Now you can see what is anything common inside, you can just cancel out, right? Anything common inside you can cancel out. So what we have taken in place of m, we have written rho dot into v, rho dot into v. You can see v here, v here, v here, right? So just cancel this v, 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 right? And we are left with rho dot a is equal to rho dot g minus rho g, isn't it? Now from here, just find out the value of acceleration. So the value of acceleration with which the body going downward inside the water, here this a, is equal to rho dot g minus rho g, and this rho dot going into the denominator over here, rho dot. So this is the acceleration which is, with which the body is sinking inside the lake of water, right? This is calculated a. Now my dear friends, if you are knowing the value of acceleration with which the body is sinking inside the water, right? This is the acceleration. Then what's next? We have seen for the section of BC, we have assumed the height. The question is what? What is the depth to which the body sinks? My dear friend, let us assume till the depth of y the body sinks, right? Till the depth of y, before returning to float on the surface. That means we need to consider to the last point, when the body sinks, right? So for the section B to C, this one, right? This is nothing but, we have assumed y, the length, okay, the depth. So for the section BC, that means inside the water, that is inside water, we need to break up the actions, what is happening inside the water, my dear friend, right? Inside the water, the initial velocity will be the final velocity of this point. For the section which we have calculated the v, that is root over 2gh, this will be the initial velocity before entering the lake, right? So for BC, that is inside water, initial velocity will be equal to root over 2gh, which we have identified, isn't it? Because we have been given h, and how we have calculated, we have seen b square minus u square equal to 2s. So velocity will be equal to root over 2gh, initial velocity inside water, inside water I'm saying. That means at this point, root over 2gh is the velocity, root over 2gh, right? This velocity I am saying at point B, right? This point B, right? Now, if this is root 2gh, then why don't you follow the equation v square minus u square equal to 2s again, right? When you just follow the equation, I'm just bifurcating this section, then we can say that the body is going to rest because it is asking what is the depth to which the body sinks before returning to the surface. So the final velocity of the body for the path BC, will be equal to 0. Why? Because what is the depth to which body sinks before returning to that surface? That means body reaches to this point, and now it is just about to take a U-turn and going to float to on the surface of lake. Right? Try to understand what I want to say. The body enters with a velocity of root over 2gh at a point B, and when it reaches C, here it is about to turn, right? The total energy is consumed for this body, and this is just returning back, U turn, right? So here the final velocity can be considered as 0, right? That means at position C, that means when it is about to return means return towards surface of lake. Why I have written it? So that you can understand what is happening, my dear friends. What is happening? The body is about to return towards surface of lake. That means the body reaches over here, it is just trying to return. Okay, that means energy over here is exhausted, right? So just apply the same formula. V square minus u square is equal to 2as. So s over here we have considered as y, the displacement, the water depth, the displacement under the water. So just put up this value y, right? Now the question is that what is the depth to which the body sinks? Okay, so this section is y. This is y which we have considered. We have assumed it, right? We have let it. So that's why this is y. The value of y need to be calculated. So this is equal to, and you can say final velocity is 0. So it will be 0. So it will be 0 minus u square. That means u, the initial velocity with which the body is entering the water, is root over 2gh. We have calculated. So instead of u square, write root 2gh whole square. Root over 2gh whole square, and here divided by 2a will give you the value of y. That means the depth to which the water body enters the water. This section which is we are about to calculate, what is the depth to which body sinks? So the body sinks to a depth of y. Okay, so this will be the answer, my dear friends. Okay, so how to go forward? How to go forward? Here, just solve it. You know the value of a which we have calculated. Just put it over here. Just put it over here. Okay, into the denominator. Right. So here you can see root 2 square is, so let me write it like this: 2 into g into h, right, divided by 2 into a, and a is nothing but this one, a. So let me write first one step is equal to the depth, or the depth to which the body sinks, right? So here you can see 2 and 2 will be cancelled out, right? 2 and 2 will be cancelled out, and here you can, we have seen rho dot, g minus rho g by rho dot is the velocity of the, is the acceleration which we have calculated, right? Now from this point, you can see 2gh by 2 times a is the value of the depth to which the body sinks, right? Now 2 into gh divided by 2g, 2 into, here 2 into a, 2 into a was there. So now the value of y is gh by a, it's gh by a. So let us write it. Let us show it. Okay, so it will be equal to, y is equal to gh by a, so gh, right, divided by a is the value of y, that is sinking level. This is the depth to which the body sink. This is the depth, right? gh divided by a. What is the value of a which we have calculated? Rho dot g, minus rho g by rho dot. This one. Rho dot g minus rho g by rho dot, right? This is the value of a. This is the value of a which we have placed it over here, right? Now you can see g, g will be cancelled, right? And we will be having the value rho dot going into the numerator, so it will be equal to rho dot h divided by, into the denominator it will be rho dot minus rho, but you can see here the acceleration which we have calculated is with a negative sign, because you can see rho dot is not greater than rho. So we can say that the, if it is considered downward, then it will be minus, because rho dot is less than, right? So we can say that acceleration is not downward, basically it is intended upward, right? So a negative sign will be introduced over here, right? So it will not be equal to rho dot minus rho, but it should be is equal to rho dot into h, divided by rho minus rho dot, because rho is greater than rho dot, right? Density of water is greater than density of body. So this will be the depth to which the body sinks, right? This will be the depth to which the body sinks, right? And this is our answer, my dear friends. This is our answer. So we have 4 options with us. One is rho h by rho minus rho dot. one is h by rho minus rho dot, one is h rho, this one, divided by rho minus rho dot, and another one is h times rho minus rho dot. So our answer will be rho dot into h by rho minus rho dot, right? So this will be our answer, my dear friends. This will be our answer, right? So we need to understand that the velocity the velocity at maximum depth and displacement is negative over here, right? So that's why a negative sign is introduced, and this displacement is going into the negative sign, so this will also considered over here, right? So that's why it will becomes here like this. Instead of rho dot minus dot, it will becomes rho minus rho dot, right? Thank you so much for watching, my dear friends. Let's be connected. Bye bye, take care, see you into the next class. See you, bye bye.